Got an exam style titration calculation here for you to try. So here's the question. So if you want to have a look at that, pause the video and then play on when you're ready for me to go through the answers. Okay, so we'll start going through the answer now. You can see I've got a little diagram here of the sort of apparatus that would have been used in this experiment. I always think it's a good idea if you can visualize what's gone on in the question, and you're more likely to be able to get your head around how to process the information. So what's happened, the students titrated sulfuric acid against a standard solution of sodium hydroxide. So the students prepared a 0.15 mole per decimeter cubed solution of sodium hydroxide in a 250 cm cubed volumetric flask. So the sodium hydroxide started out in here. It's 0.15 moles per decimeter cubed. The sulfuric acid is added to the burette. So sulfuric acid's in there. You can see I've already labelled that up. So the student pipettes 25 cm cubed of the sodium hydroxide, and obviously that's gone into the conical flask. So we've got 25 cm cubed of the NaOH gone into there, and the mean titer was found to be 26.3 cm cubed. So the sulfuric acid required for neutralization was 26.3 cm cubed. Okay, so the first thing we can do is calculate the moles of sodium hydroxide used in the titration, because we know the concentration of it and we know the volume used. It was 25. That's the first thing I'm going to do. Okay, so moles of sodium hydroxide, concentration times volume gives us the moles, 3.75 times 10 to the minus 3. Okay, so the next thing I'm going to do is we're going to use the balanced chemical equation to work out how many moles of sulfuric acid must have been present in that average titer, 26.3 cm cubed. So the ratio is 2 to 1, so we need to halve the moles of sodium hydroxide to get the moles of sulfuric acid. So that comes out at 1.875 times 10 to the minus 3. So now we know the moles of the sulfuric acid, you know the volume that it was in. We can turn that into a concentration, moles divided by volume. So that's coming out as a calculator value of 0.07129 ... So just keeping all the numbers in the calculator to 3 significant figures. That's what we have to give our answer to. That's going to be 0.0713 moles per decimeter cubed.